Hey guys, it's Shahir from 5 Academy. Welcome back to another 5 Academy video. So today we're going to be going through a full 60 question, 60-minute ACT math test. I'm obviously going to take a little longer than 60 minutes so I can describe each problem to you and really break it down so you understand what's happening. But the question is, why are we going to do this? Why are we going to go through all of these problems? Well, the answer is because the more problems you go through, the more tests you take, the more content you review on the exam, especially on the math and English tests, the more skills you'll learn and the more familiar you'll become with the content that's asked about on every single one of these practice tests. It's the same skills again and again, and you can learn them at least to an extent through your practice tests. Now, if you want to learn these in a bit more advanced way, more than just taking practice tests and watching videos like this, we have on our website actually a resource where we sort all of these practice tests by skill. So you can input your practice test results, essentially take the test on our system, and we will give you data and insights on which skills you're doing better or worse on. So if you want to check that out, that's on our website. You can get access to that. And the very last thing I'll say before we get started, you can also get more of these tests for free, as well as this same test PDF. So you can take the test on your own, do it, simulate it just how you'd want to. So I recommend you do that before you watch this video so that you can take the test, correct it, grade it. There's a score chart at the bottom of this PDF that I'm looking at. You can do that and then come back to this video at the end and essentially watch the parts of the video for any problems you didn't really understand or that you want to learn and understand a bit better. So I'd advise that you do that and make the most of that. We won't go super in depth. We won't spend more than 2-3 minutes on any given problem here for the most part. So if you want more in-depth analysis for any of these skills, because there are, about 30, 40, 50 skills here in this video, then definitely check out our website. We have lots of resources, tutoring programs, free and paid, that help students. And you can actually schedule free tutoring with me to go over some of these problems if you want. I will link free tutoring sessions with me and a scheduler for that down below. It takes literally 30 seconds to a minute to set that up. All right. So without further ado, let's get started. First problem, if 6 times x minus 7 parentheses equals 4, then what does x equal? So we can do this by distributing the 6 to the x and the 7. So let's distribute that out. 6 times x minus 6 times 7, which is 42, is equal to 4. Let's add 42 on both sides. 6x equals 46. That means if we divide both sides by 6, we get x equals 46 over 6. If we divide both top and bottom by 2, we get 23 over 3. The daily fees for camping at this campground are $15 per day and $5 per person. Last summer, daily fees were paid for D days and P persons. Which of the following expressions gives the total amount collected for daily fees last summer? So let's just say we were going for 3 days, 7 people. How much would we pay? $15 times 3 days, right? And then we'd pay $5 per 7 persons. That means we're paying 45 plus 35 equals 80, right? That's our total fee. Now, in this case, what did I really just do here? How can I get a function out of this? Well, we're told that we're pricing for D days and P persons, right? That's what it says right here. So instead of plugging in a number for D or P, I can just plug in D or P itself and just make that a variable. So your answer for 2 should be B. A function f of x is defined as f of x equals negative 4 times x to the third. Which of the following is f at 3? So you're just going to plug in 3 for x, negative 4 times 3 to the third, which is going to give you negative 4 times 27, which is just 3 to the third, and then negative 108 is going to be your answer if you plug it into the calculator. A rectangle has an area of 48 feet squared and a perimeter of 32 feet. What is the length of the longest side of the rectangle? So if I draw a rectangle, I have length, width, length, width. The area is going to be length times width. Okay? The perimeter is going to be the sum of all of the side lengths. So in this case, that's just going to be L plus W, which is 2L plus 2W. And I know that my area is 48 feet squared. My perimeter is 32 feet. Okay, so what I have here is 2 functions and 2 unknowns. I can create a system of equations to solve. So the way I'm going to do that, let's move this, make it a bit smaller. That's good. Okay, I'm going to take this first equation right here and solve it for L. Okay, L is going to be 48 divided by W, if you just divide both sides by W. Then I'm going to plug this L in here. So I get 2 times 48 over w plus 2w equals 32. That becomes 96 over w plus 2w equals 32. And then I'll multiply each term by w because I want to solve for w. You'll notice that if I multiply everything by w, this turns into a quadratic. 96 plus 2w squared plus 32w, equals 32w. Yeah, I can move everything to one side. 2w squared minus 32w plus 96 equals 0. Okay, I'm going to quickly delete what's up here. Move this up. Now I'm going to divide everything by 2. So we get w squared minus 16w plus 48 equals 0. Now I can factor this or do the quadratic formula. I like to factor it because I see that there's factors of 48, 12, and 4, or negative 12, negative 4, that equal negative 16 when you add them together. So w minus 12, w minus 4 equals 0. That means that width is going to be either 12 or 4. Really, that just means length or width are going to be 12 or 4. So your length is going to be 12, your width is going to be 4. That means your answer here is D, which is 12. Okay? And if you multiply these two together, you get 48. If you plug these into the formula 2L plus 2W, essentially 2 times 12 plus 2 times 4, you end up getting the answer that I said here. For two consecutive integers, the sum of double the smaller and triple the larger is 63. What is the sum of the two integers? So two consecutive integers, let's just say, for example, it's 33 and 34, right? You can make a system of equations out of this. So let's just say the first one is x, the second one is y, and I know that y is going to be equal to x plus 1. Or literally, I could say the first integer is x, and then the second one is x plus 1, okay? And then I can go through and solve this. So we're told two consecutive integers, the sum of double the smaller number, so the smaller number is going to be x, right? So let's just kind of convert this statement into words. So the sum, we're going to be adding two things together, and then it says later on is 63, okay? The sum of double the smaller number, so the smaller number is x, double the smaller number is going to be 2 times x, okay? The sum of this and this, so that means this is just the first term. Now the second term is going to be what comes after and triple the larger. So the larger integer is what? X plus 1. And it says triple, which means we're multiplying it by 3. Okay, so the sum, let's just erase this, kind of clean it up, walk through it again. The sum plus of double the smaller, 2x, and triple the larger equals 63. Okay, so we have all the terms there. All we need to do now is solve it. So 2x plus 3 times x plus 1 equals 63. I can distribute the 3 out, so we get 2x plus 3x plus 3 equals 63. I can combine these x terms, and then I can also move 3 to the other side by subtracting 3 on both sides. 5x equals 60. Divide both sides by 5. X equals 12. Okay? Now, the question doesn't ask just for what the smaller number is. That's why you don't see 12 as an answer option here. The question's asking for what's the sum of the smaller and the larger. So what essentially is x plus 1. So I know that x is equal to 12. That means that this is obviously going to be 13, right? If I add those together, you get 25. And that's your answer. Given a equals bc squared and a equals this, b equals this, which of the following is c? Okay, so let's just plug in what we know and see what we end up with. It looks like we have 3 unknowns and three variables, and 2 of them are known, so we can solve for the third. 250 equals 10 times c squared. So I can immediately solve for c, just divide both sides by 10 and then take the square root. So you get plus or minus 5. The only answer option here that we see is 5. The first term in a sequence, geometric sequence, is 3. The rest of the sequence continues as is shown below. Which of the following is the 8th term in the sequence? The best way to do this is to just continue the pattern and to notice the pattern. So it looks like here I'm doing times negative 2, times negative 2, times negative 2. So we're going to continue that. What's negative 24 times negative 2? You get 48, and then I get negative 96, then I get 192, then I get negative 384. 7 should be B. In which of the following ways are the fractions arranged in increasing order? The best way to do this is to take each of these fractions and convert it to decimal form. So 2 over 3 is equal to 0.6 repeating. Essentially, you could think of it this way. 3 over 5 is equal to 0.6, just flat, 0.60. And then we have 5 over 8, which is equal to 0.625. Now what I can do is I can just sort these in decimal form because it's obvious which one's larger than the other. Clearly 2 over 3 is the biggest, so I'm going to put this here. And then these two are already arranged as is needed, okay? So from left to right, these increase, and this right here gives me my order. All I have to do is sort these and sort these accordingly, and I have my order. 8 should be B. Which of the following is the side length in feet of the isosceles right triangle shown below, given that the hypotenuse is 6 feet long? So the hypotenuse is always the longest side. It's also the side that's opposite the right angle. Okay? Now, the side length in feet of the... so when it says side length, it's asking for the leg length, the side leg length, okay? So we know that these two have to be the same because it's isosceles. Isosceles means that there are two side lengths that are the same. Clearly, this can't be the one that's the same, that has another that's the same dimension, because this is the hypotenuse. It's the longest side. Okay, so we know that these two are the same. Also, since it's an isosceles right triangle, we know that both of these angles are 45 degrees. So we have a couple different ways we can solve this. One of them is to use a sine cosine tangent ratio. So I could say sine of 45 is equal to opposite over hypotenuse. So sine of 45 is equal to x over 6. I can just solve for x. X equals 6 sine 45. You can do this on your calculator. You'll get the decimal equivalent of 3 squared of 2, I believe. So if you do sine of 45, you multiply by 6, you'll get 3 square root of 2, just to confirm. Okay. You can now you don't just want a decimal equivalent. If you get a decimal equivalent and you're not sure which answer option to choose because none of them are in decimal form, you could just plug in each answer option and find the decimal equivalents of each and then just match your answer here. Otherwise, if you remember that sine 45 is equal to square root of 2 over 2, then 6 square root of 2 over 2 is going to give you 3 square root of 2. Okay? So that's another easy way to solve it. The fastest way to solve it is to do this. So you need to keep in mind that these ratios are true for any isosceles right triangle. If the side lengths are labeled as x, that means that the hypotenuse is going to be that same x multiplied by square root of 2. Alternatively, so you see, to go from here to here, you multiply by square root of 2. Okay? Or to go from here to here, you divide by square root of 2. Okay? Now, since I already know this, all I have to do is divide by square root of 2. Or essentially take 6, which is 3 times 2, and then divide it by square root of 2. 2 divided by square root of 2 is just going to be square root of 2, so I end up getting 3 square root of 2, okay? That's another way to do it. Again, don't confuse yourself too much. I'm just giving you different options. If any one of those made sense, then stick with that one method. In the coordinate plane, which of the following is the slope of this line? So slope is given by this form, where m is your slope. So we need to basically just solve this for y. I can start by subtracting 2 on both sides. So I end up getting 3x minus 2 equals 5y. Let's write it by flipping right and left. So you might think, okay, mx plus b, we're good, right? But the thing is, y has to be by itself. I need to get rid of this 5. Okay, let's do just that by dividing 5 on both sides, or essentially all the terms. Y equals 3 over 5x minus 2 over 5. Now that right there is your slope. So 10 is going to be b. Which of the following is a factored form of the expression? The way you can factor this is with the box method. The way you do the box method is you write the first term in the top left of your 2x2 box. You write the last term, the c term, in the bottom right. And then what you do is you multiply that coefficient of the first term with the constant in the last term. and you end up getting negative 24. This is what you do when you have negative 24. You think of factors of negative 24 that add or subtract to the middle number, to the b term, to negative 2. Okay, so what are the factors of negative 24? We have 1, 24. That pair doesn't work. 2, 12. That pair doesn't work. 3, 8. That pair doesn't work. 4, 6. So we can get negative 4, 6 or negative 6, 4, and these two will actually add up to negative 2. Okay, now I'm going to have to choose this pair because when I add negative 6 plus 4, I get negative 2. But if I add 4 plus negative, if I do 6 plus negative 4, I get positive 2. I don't want positive 2, I want negative 2, all right? So I'm going to take both of these, negative 6 and 4, and I'm going to write them in their own box with an x term, okay? Because these two sum to give me the middle term. Think of it that way, all right? So really what I just did is I expanded this over 4 boxes, the 3 terms over 4 boxes, by splitting the middle term into 2 factors that I know can multiply to give me the a and c term product, okay? Now what I do, last step, and if you've seen the factoring video, you've seen how I do this. So what you do is you take each column and you find a common factor, the greatest common factor of each column, and you write them up here. You do the same thing for each row. You write the greatest common factors on the side, okay? So I'm going to do that for the first 2 columns. Greatest common factor of negative 6x and negative 8 is negative 2. And if what you do with the sign is you take the sign of whatever term you've written here. Okay, so if this is negative, I'm going to have negatives here and here. If this is positive, I'm going to have positive there, okay? So since that's a negative 6x, I'm going to have a negative 2. Okay. Greatest common factor here is x. Greatest common factor here is 3x. You can include x in there because they both have it. Here, the greatest common factor is going to be 4. So your final answer is going to be x minus 2 times 3x plus 4. And just to check, make sure we did it correctly, what you can do is just FOIL it out. So you do 3x squared plus 4x minus 6x minus 8. And that does check out. It gives you the same thing. It's actually exactly what we have down here. All right, so we've factored that with the box method. For more information on that, check out the factoring video, the skill video for factoring. The sum of the real numbers x and y is 10. The difference is 8. What is the value of x, y? So we know the sum is 10. X plus y have to add up to 10. It says their difference is 8, meaning that 1 minus the other is 8. The thing is, it doesn't matter how you order the 1 minus the other, because as long as the sum is 10, it doesn't really matter what you get for x and y individually, because again, you're just going to multiply them at the end. So it doesn't matter which one is which. It just matters that you get the right values. Okay, so I'm going to just stick with doing it this way because it's just a bit more logical. Now, I have a system of 2 equations and I have 2 unknowns, so I can use substitution or just actually use elimination. Let's just do that. Just add both of these equations to each other and I'll get one of the variables. So 2x plus 0, because these y's will cancel when I add these 2 equations together, will give me 18. If I add 10 and 8, 2x equals 18. That means x is equal to 9. Okay. Now, if I remember that x minus y is equal to 8, that means 9 minus y is equal to 8, and that means that y is equal to 1. So y is 1, x is 9. 9 times 1 is just 9. Okay. Which of the following is the least common factor, least common multiple of these 3 numbers? Now, one way you could do this is to just take each answer option. If you want to cheat on the through the problem, take each answer option and just divide it by all 3 of the numbers and see what's the smallest answer option that's divisible by all 3 numbers. Okay? So for example, I'm going to start with the smallest value. Let's do 240 divided by 36. Do 240 divided by 40. 240 divided by 48. And check, do I get a whole number for all of these? 240 divided by 36, that does not give me a whole number. So for that reason, since it's not divisible by 36, 240 is not actually a multiple of 36. Okay? So this is out. You're going to have the same issue with 500. 720 will be the smallest one that's divisible by all of these, okay? Now, if you want a more holistic method, a more in-depth method that really helps you understand the skill behind this, you can make a factor tree of all three of these numbers. And then you take the factor trees of all three. I'm not going to go in depth on this, but you take the factor trees of all three, you find all of the unique factors that are across all three of these prime factorizations, and then you multiply those unique factors together. There's more on that in the video, but again, if with this type of problem, you don't really need to know what you're doing. You can just reverse solve it by checking each answer option, like I showed you. In ABC, the sum of the measures of A and B is 53, and note that this is a triangle. Which of the following is the measure of angle C? So let me just draw a random triangle, A, B, C. This is definitely not drawn to scale. So we know angles A and B, these two angles add up to 53 together, okay? Not each, but together. Let's just label this one X, okay? So how can we use that to find angle C? Well, we know that angle A plus angle B plus angle C has to equal 180 degrees because the interior angles of a triangle always add up to 180 degrees. We know that angle A plus angle B already equal 53. So 53 plus angle C will give me 180. That means that angle C is equal to 180 minus 53, which is just going to be 127. All right. So I really just only had one unknown in that problem. We can quickly solve by solving for that unknown. Absolute value. Okay. So what you do is you always start with the innermost operation. So -7 plus 4 is equal to -3. So I'm going to rewrite this just with this simplification. -5, absolute value of -3. Now what's the absolute value of -3? It's just +3. So -5 times +3 is going to give me -15. Okay. For the triangle shown below, which of the following is the value of tan of theta? If you remember your SOHCAHTOA acronym, then this problem should be trivial. So TOA, tan theta, equals opposite over adjacent. TOA, right? Now, opposite is the side that the angle opens up to. B. Opposite over adjacent. And the adjacent side is going to be the side that the angle is touching. Now you might think, okay, the angle is touching two sides. It's touching C as well. Well, C is the hypotenuse. And how do you know it's the hypotenuse? It's because it is opposite of the 90-degree angle, the largest angle. So that means it's the largest side if it's opposite the largest angle. Okay, so opposite is here, adjacent is, opposite, adjacent, B over A. How do we simplify this expression? So what I'm going to do is I can take this negative and distribute it to each of these terms and then just turn this all into addition, okay? So we're going to take 6a minus 9b plus 2c plus -3a plus 4b minus 4c, essentially just flipping the signs of each of these terms, okay? Now all we have to do is add, combine like terms. So we have a 6a and then we're subtracting a 3a. So we have to have 3a in our answer, okay? We have a -9b, and we're adding a 4b. That gives me -5b, okay? So we have to have a -5b in our answer. That means that these two are out. And then you'll see if you do 2c minus 4c, you'll end up getting -2c, okay? So the problem checks out. 17 should be C. 12% of 50 is 1/6 of which of the following numbers? So 12% of 50, how do we find 12% of 50? What you do is you take the percent and you divide it by 100, and that gives you the decimal equivalent of that percent. So 12 over 100 times 50 is, that can be converted to an equal sign, 1/6, you just literally write 1 over 6, of which of the following numbers? Some number, okay? I'm going to plug in x. Now, all we have to do here is just solve for x. As long as I can do all these operations or reverse some of the operations, I should be able to get this answer very quickly. Okay? So, I can do this on my calculator. Let me actually, before I do that, let me get rid of this 1 over 6 so I can isolate x. So the way you're going to get rid of 1 over 6 is just multiply both sides by 6. So your answer is going to be 6 times 12 over 100 times 50 is equal to x. This gives you 6 times 12 times 50 divided by 100. You get 36. Okay, so that number x is 36. Very simple. It's only two operations, really. A circle in the standard coordinate plane passes through this point and has its center at this point. Line segment FG is a diameter of this circle. Which of the following are the coordinates of point F? So let's go ahead and first plot the points we have. We want to visualize this problem so that it becomes a little bit easier to interpret. Okay, so we have passes through 5, 5. Easy to plot. It's going to be even. So let's label that as G. And the center of the circle is at 3, 1. So it's going to be somewhere like this. Okay? This is point E. That's the center of the circle. So your circle is going to look something like this. Make it a bit smaller. There we go. Okay, that's your circle. Now, it says that FG is the diameter of the circle, which means that it goes all the way across from G to F. F is down here somewhere. Okay? Now, we don't know the coordinates of F. So how do we find the coordinates of F? What I would recommend you do is think, what do you have to do to go from G to E? Well, you have to go down, right? And then you have to go left a bit. So in order to go from E to F, you're going to do the same thing because E is a midpoint. That means that whatever you do from G to E, you have to go from E to F to get literally E to F. It's the same exact length and distance of travel. Okay, that's what a midpoint is. So how do we know how far up and down we're going from G to E? Well, if I look at the coordinates 5, 5 and 3, 1, I know that the x value is going left 2, right? That's why it changes by 2. So we're going minus 2. The y value goes down by 4. So I'm going to do the same thing from E to F. Down 4, left 2. So you can take your E point, your midpoint, and subtract 2 from the x coordinate. And then subtract 4 from the y coordinate. 1, negative 3. And this looks like 1, negative 3. It looks like we did it properly. 19 should be E. All right, moving on. Alex doesn't know if he should buy a season pass ticket for his college football team's 18 home games this season. The price of an individual ticket is this much, and the cost of a season pass is this much. What is the minimum number of home football games he must attend for the cost of a season pass to be less than the total cost of buying individual tickets for each home game he watches? Okay? So obviously, if you're only going to see 2 or 3 games, you'll pay like $30, $40 in tickets. And that means that the season pass is not worth it. This question is really asking, how many tickets would you have to buy? How many individual tickets until you get to the $150 mark or exceed the $150 mark, where the $150 price point becomes more worth it? So one way to do this is just list out all the multiples of 12, right? See how many multiples it takes you to get to 150. You're going to get to 144, and then you're going to get to 156. This number is 12 times 13. So 13 tickets. At 13 tickets, you're going to be, if you list this out, you'll see that you are exceeding the season pass price. So if you're going to go to 13 or more games, that means that it's better to just buy the season pass. Okay? The other way you can do this is just divide $150 by 12 tickets and see how much, $12 per game. Per game, right? What this will do is it'll give you an answer of like, I think 12.5 or something. Let me just check that. 150 divided by 12, it should be 12.5. Gives you 12.5 games, okay? At the original price. So if you go to 12.5 games using the original rate, you'll hit $150 flat. So anything more than 12.5 games is going to be 13 games or more, right? That's where the $150 becomes worth it, right? So you can use this to get that number 13. You'd obviously have to round up because you can't go to half of a game. You can either go to 12 or 13. So if you go to 12, it's not worth it. If you go to 13, it is. Okay, that's why 20 is going to be C. Let's move on. At an ice cream parlor, Kim can choose between 2 cones, 4 flavors, 5 toppings, and 3 syrups. If Kim must choose one item from each category to make her ice cream sundae, how many ways can she make her ice cream sundae of choice? So it's asking for unique combinations. The way you're going to do this is just multiply each of the options, the number of options, together. And you end up getting, I believe, 120. 21 should be E. Which of the following is the product of these two numbers? So these are complex numbers. You can find the product by just foiling and treating I like a variable. And then at the very end, we'll apply the property of I squared is equal to -1 to get our final answer. Okay? After we FOIL. So first, we're going to do 4i times 2i. Again, that's just this. Then you do outer, the two outer numbers, plus 4i times -3. Then the inner numbers, 5 times 2i. And then the outer numbers, 5 times -3. Okay? This will give you 8i squared minus 12i plus 10i minus 15. Here is where you can apply the property. So remember, I squared is equal to -1. And then these two numbers in the middle, they both have an I term. You can't really do anything with just an I term, so you're going to have to leave that there. But you can combine the two terms, okay? Treat it like as if it was x. So this is going to turn into 8 times -1 minus 2i minus 15. 8 times -1 is going to be -8. So you end up getting -23 minus 2i. So your answer for 22 is going to be D. Lines A and B lie in the standard coordinate plane. If both lines are parallel and the equation for line A is this, which of the following is the equation of B if it passes through the point 2, 8? Okay, so imagine we know that they are parallel, which means that they are going to have the same slope. So the first thing we know about B already is it goes through and has the same slope. The only other thing we need to identify is that y-intercept, okay? How are we going to identify the y-intercept? We can plug in values for the y-coordinate and the x-coordinate, and those values are right here. And then what that'll do is that'll leave us with just one unknown, and we can solve for that one unknown. I'll just label it as a question mark, okay? So this is our y value, or essentially we'll label it as b, because it's the b equation, and this is our x value, okay? So 8 is equal to 3 times the x value, 2, again, minus question mark, okay? We subtract 6 on both sides. Sorry, we're adding this. So we get 2 equals question mark. So your question mark is 2. Your equation for b is going to be 3x plus 2. 23 is B. Scientific notation. If it's multiplication or division that you're doing, the best way to do this type of problem is to divide the problem into two different problems. So we first do just the decimal part, the easy part. You can do that on your calculator. Actually, you can do the whole thing on your calculator. If you just plug it in, I'll show you how to do that. But if you're not doing it on your calculator, you can do 5.1 divided by 1.7. That's equal to 3. So you know you have to have a 3 in your answer. That's the easy part. I mean, that's really not what the question is testing you on. The second part, if you use properties of exponents, do it by hand. This turns into, since they have the same base of 10, you can just subtract the exponents. So when you have 10 to the x divided by 10 to the y, your answer is going to be 10 to the x minus y, okay? In this case, x is equal to -9, y is equal to -12. So your answer, this is going to be 10 to the -9 minus -12. Don't get your signs mixed up. Just because there's extra negatives here doesn't mean that you can get rid of that middle negative there. That middle negative is the most crucial part of that whole problem, of the whole process here, okay? Because what's going to happen, this is going to turn into a -9 plus 12. When you have a minus a negative, it turns into a plus. Think of it as a plus, okay? So this becomes 10 to the third. 3 times 10 to the third, all right? Simple as that. Your answer should be this right here. Now, the other way to solve this in seconds using your calculator is to plug in 5.1 capital E. There's a capital E button on your calculator. If depending on which calculator you have, you can figure out how to press that. -9 divided by 5.1 capital E, or sorry, we're doing 1.7 on the numerator denominator. minus 12, okay? This will give you 3 capital E minus 3, or sorry, plus 3, 3 capital E 3, and that just corresponds to 3 times 10 to the third. The capital E is just short for 10 to the, really, that's all it is. It's the way your calculator quickly interprets that. You could also type the whole thing out with the exponents if you want to type it all out. Just got to make sure you do your parentheses properly so you don't mess things up. The average of 7 test scores is 85. If the lowest score is dropped, the average of the remaining increases to 88. Which of the following is the value of the lowest score that was dropped? So if we remember, the equation of an average is what? Average equals the sum of numbers divided by the number of numbers. Okay? So I know that the original average is equal to 85. So I'll just write that here. The original average is 85. Original sum was 7. Sorry, the original number of numbers is 7. So the sum has to be 85 times 7, right? In order to make this all true and make it all work. It's 595. Okay? That's 85 times 7. All right? Now, it's telling us that if we get rid of a certain test score, the average, I'm going to create a new average, average 2. This goes up to 88. The sum, we don't know what happens, and the number of numbers is obviously 6. So that means your sum does what? Your sum changes to 88 times 6 in order for this to be true. That's 528. What I can do, and if I want to find the value of that last test, I can just subtract these two numbers. So 595, if you do that on your calculator, and you subtract 528, you end up getting 67. And that's the value. That's the difference between the 7 and the 6 test scores. The difference was just that one score that was dropped. Okay? Another way to do that is to put all of that into one equation. So you could create one equation with these 6 tests and then this extra test that you don't know. Have the extra test be the unknown. So the average will be 85. We're going to divide that by 7, right? Just write out your sum as 88 times 6 plus x, where x is the unknown dropped. So you multiply both sides by 7, you get 595 equals 88 times 6 plus x. Really what you're doing is 595 equals 528. Remember these two numbers, we just calculated them. And then your final answer is just going to be the difference between these two numbers. Okay, that's how you do this one. A couple different ways to do it. In a bag of marbles, there are 22 red marbles, 36 blue, 38 green. If Greg wanted to increase the probability of drawing a red marble to 1/3, how many red marbles would he have to add to the bag? So what's the current probability of drawing a red? Well, the probability of anything, if you don't know how to calculate probability of an event, is the number of desired outcomes divided by the number of total outcomes. So the probability of drawing a red currently is the number of desired outcomes, 22, divided by the number of total outcomes, which is just the sum of all of those marbles. How many marbles are there? 36, let me just add that on my calculator, plus 38 plus 22, 96, and this is less than 1/3. I think this equals something along the lines of 0.27. So it's 0.22, 0.229, okay? So that's obviously less than 1/3. We need to increase. Now, how do we increase the probability? It says by adding red marbles to the bag, okay? So if I add red marbles to the bag, what does that mean? If I add 1, what happens? My probability of red, when we do plus 1, is what? 22 plus 1, right? Because I added 1 red marble. Divide by 96 plus 1. Because again, in the numerator, I added 1 red marble. And in the denominator, I also added 1 red marble to the total, right? Because that increase. What does this give me? It gives me 23 divided by 97, which is 0.237. Compared to the 0.229 that I was at before, this is definitely closer. Which means that if I keep adding them, I'm going to keep getting closer and closer to my desired value of 0.33, repeating, right? Now, you could just keep going like this, do 22 plus 2 over 96 plus 2, or really just check each of these answer options. So like 22 plus 9 over 96 plus 9. You can go through and do that. That might take you a minute or two, but that's one way to solve it until you get the right value. The best way to do it is to create an equation. Instead of checking values, you check an unknown number, x, and you find what does that x value have to be for me to equal a probability of 1 over 3. So take that same equation, 22 plus something divided by 96 plus something has to equal 1 over 3, right? The probability has to equal that. Just make that something x. What do I have here? I have one equation with one unknown, so I can solve for that unknown. Let's do some cross multiplying and dividing. So I'm going to multiply both sides by essentially 96 plus x, and then multiply them by 3 as well. So cross multiply. 3 times 22 plus x equals 96 plus x. I can distribute the 3 out. 66 plus 3x equals 96 plus x. I can subtract 66 on both sides, subtract x on both sides. This turns into a 2x. This turns into a 30. That means I need to add 15 marbles to make the probability of a red 1 out of 3. And do you want to check the answer? Let's do it. So probability of red is equal to 22 plus 15 over 96 plus 15. That gives me, I believe, 37 over whatever 37 times 3 is. 111. And does 37 divided by 111 equal the desired value? Yes, it does. It equals 0.3 repeating. Okay? Because 37 times 3 is equal to 111. That's how you solve this. If g, f, and h are positive integers such that f to the h is equal to y and g to the h equals z, then what does y, z equal? So y, z is going to just equal f times f to the h times g to the h. Okay? Simple as that, but the thing is that's not one of the answer options. So how do we combine this and get one of these? Well, the thing is, when two numbers have the same exponent, for example, 2 to the third times 6 to the third, you can actually just multiply the two bases together and raise the entire product, which is 2 times 6 in this case, to that exponent. Okay? That's a property of exponents. So what you can do in this case is just multiply fg together, raise it to h. And that's what this is. Now, you can't use this answer option, for example, because it might be tempting to add the two exponents together, h plus h equals 2h, but you can only do that when you have multiplication with the same base, okay, and the exponents might be different. So for example, if I had x to the third, or if I had, if the problem was, let's say f to the h times f to the a, then I could do f to the h plus a, okay? Because they have the same base. But when they have this different bases, in this case f and g, but the same exponent, you can multiply the bases together, okay? So if the bases are the same, you combine the exponents. If the exponents are the same, you can combine the bases, okay? Think of it that way. Scientific notation, again, you see it here, and we're adding this time. You can quite literally plug this into your calculator, and it might, if you have a graphing calculator, it might just give you an answer in the form something, 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 e something, something, something. And if it does, then you essentially know how to interpret that. I did that in the problem up here, how to interpret scientific notation on a calculator. But assuming you're not doing it that way, let's do it by hand, just the proper addition with the way that they teach you in school. Let's convert this to scientific notation. So in order to move the decimal from here all the way to 8.4, what do I have to do? 8.4 times 10 to the what? So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 6.3 times 10 to the what? 1. So I'm going 3, 6, 9, 10, 11. Okay? Cool. So I moved my exponent. Now what I'm doing is I'm adding these two together. So I can just add, since they have the same bases, I can just add the exponents together like this. So 8.4 plus 6.3 gives me what? 14.7 times 10 to the 11. That's not one of the answer options, but it's close to one of these, right? It's definitely not this. This is different. So between B and C, how do we know which one to choose? So we need to move the decimal. Whenever you write scientific notation, it has to be the decimal. The number in front of the decimal has to be in the ones place. You can't have 14.7. It has to be 1.47. Okay? So how do I know if I change it to 1.47, what does that exponent on the base of 10 become? Well, the way you're going to know is, this is a very easy way to think about it. If I take this number and I make this one smaller, that means I have to make this one larger to compensate. Bigger, okay? So I made this smaller. That means I'm going to make this bigger by how much? It's by the same factor that I made the other number smaller. So what did I do? I divided this by 10. That means I have to multiply this by 10. So if I divide by 10 here, I'm going to multiply by 10 here, okay? Meaning I take the original and I multiply by 10. This becomes 10 to the 11th times 10 to the 1st, and that essentially just becomes 10 to the 12th. 1.47 times 10 to the 12th. Very easy way to think about that. You'll never get it wrong. Think of it as compensating. What fraction lies exactly halfway between 1/2 and 2/3? You can go ahead and plug in decimal equivalents of these. So 0.5 plus, like you can go on your calculator and plug in 1 divided by 2 plus 2 divided by 3, and then take that answer that it gives you and then divide it by 2, and you'll get a decimal. The decimal will be whatever the equivalent of, so it'll be 0.583. Repeating. And then what you could do is you could just check which of these equals 0.583. Just off the top of your head, you know that this won't. It might be one of these three. Okay, very quick, very easy way to back solve the problem. Now, if you don't want to do it that way, if you want to understand how to actually do it using the fractions and combining denominators and whatnot, so in order to add, you have to first add these together, and then you have to find the average by dividing by the number of essentially fractions there are, okay? So the first step is adding it together. In order to add it together, you have to have the same denominator. So a common denominator that you can use is just 6. Just multiply the two denominators together. I'm going to multiply this by 3/3, multiply this by 2/2. Why do I do this? Why do I multiply by these seemingly useless fractions? It's because I want the denominators to be the same. So I'm going to multiply essentially by a fraction that has, that this entire fraction is just equal to 1. Same here, it's just equal to 1. But it has a denominator that is the same as the other fraction. I'm compensating essentially for the missing factor in the denominator. So I have to think, how do I go from 2 to 6? Well, I just multiply by 3. And since I don't want to change the value of the entire fraction, I can just multiply the numerator by 3 as well. What this gives me in this case is 3/6. It's the same number, 1/2, 3/6. It still equals half, but I rewrote it with the denominator that I want so that I can add it to the other number with, again, that'll also have the denominator that I want, okay? In the other case, you end up getting 4/6. 7/6 is your answer. And now, again, keep in mind, you have to divide 7/6 by 2, which is the same thing as 7/6 times 1/2, 7/12. If this is this, then what does x equal? Well, if I'm solving this, I notice that the numerators of this are the same, so they essentially cancel out. But the denominators are different. I can make the denominators equal to one another. Divide both sides by square root of 13. X equals 13 over square root of 13. What does 13 over square root of 13 equal? It's just square root of 13. Because square root of 13 times square root of 13 is equal to 13. Okay, you can think of it this as square root of 13 squared on the numerator. All right, otherwise do it with your calculator just to confirm. You can do this all in decimal form and then check which decimal answer option equivalent, like convert all these to decimal form by just plugging them into your calculator. If you do the problem in decimal form, if you calculate this in decimal form, you can find the right answer just by matching decimals. James has a notebook with 100 pages. He used 8 pages of the notebook and lets his 4 sisters split the rest of the pages evenly amongst themselves. How many pages do each of the sisters get to use? So he uses 8 pages. So immediately, 100 minus 8. Like, for example, if we want to find how many pages are left, right? After he uses 8 pages. If I use 23 pages, for example, and there's originally 100, then that means that the leftover is going to be 100 minus 23 pages, which is 77 pages. It's not going to be 8 minus 100 because that would give me 23 minus 100. And there's not a negative number of pages left. There's going to be a positive number, okay? So we're going to subtract 100 minus a. Okay, that's how many pages are left. Now, he has to let the rest of his sisters split evenly those pages. How many do each of them get? Well, it's just going to be that number divided by 4. In the case of a equals 23, it'll just be 100 minus 23, which is 77, divided by 4, which is going to be some decimal. They can split some pages here and there, but the point is, this is how you do it. It's not divisible by 4. It's not divisible by 25 because while 100 divided by 4 is 25, that doesn't mean that we're dividing the pages into 25 parts. There's no reason to divide into 25 parts. We're dividing the 100 pages or whatever, 50, 75 pages into 4 parts. Given the following triangles that have equivalent corresponding angle measures, which of the following does x equal? If they have equivalent corresponding angle measures, they are similar triangles, which means that essentially one is a scale model, a scale version of the other. When one is a scale version of the other, the ratio of side lengths from triangle to triangle is constant, okay? So if I can find one ratio, which in this case is times 3, that means that this other side length here, since it corresponds, it's the left side length in this orientation, is also going to be times 3. This is also going to be times 3. So 3 times 3 is 9. 4 times 3 is 12. Okay? These two triangles hash out like this. So your answer for x is going to be 9. Find the value m that makes the following two lines perpendicular. So perpendicular lines have slopes that are negative reciprocals of one another. So in this case, if I have 3, really that's just equal to 3 over 1. So in order to get a negative reciprocal, let's just take it step by step. I first have to make this negative, and then I have to take the reciprocal by flipping the numerator and denominator. So if a line has negative 1 over 3 versus a slope of 3, those two lines will be perpendicular. They can look like this. They can look like whatever. They'll form a perfect x, a squared x. A cylindrical can of soup has height 6 inches and unknown radius. Given that the volume of a cylinder is known by this equation, where r is the radius of the cylinder and h is the height, which of the following is the radius of the can in inches if the volume of soup in the can is this and the can is half filled? Okay. So r is the unknown. We're solving for that. The volume they give us, 27 pi over 4. The only thing is, how do we get height? They don't give us a height value. I mean, they give us this, but this is the height of the can, not the height of the fluid in the can, because the can could be this high and the fluid could be just down here, right? So this is going to give us an inaccurate value if I use that value versus if I use this value for my height. We're going to get a completely different value for R. The thing is, it says the can is half filled. So relative to the 6-inch total, we are actually at 3 inches height of fluid in the can. Okay, so I'm just going to make this equal to 3 and then solve for R. So let's first solve this for R by dividing V. So R is going to be equal to V over pi h square root. If you just do some algebra, you divide both sides by pi and h and then take the square root. This is going to give you, when I plug in the numbers with h equal to 3 and v equal to this number, let's see what we end up getting. 27 divided by 4, divided by 3, all to the half, you end up getting 1.5, which is right here. Okay, so it's 1.5 inches in radius, which makes sense for a can, right? As opposed to this very large number for a radius, those two do not make sense. A computer mouse's position tracking accuracy is directly related to its battery power. Given the following table of values, which of the following linear equations correctly models the mouse's position tracking accuracy as a function of battery accuracy? Battery power. Okay, so I have a table. It might be linear. I mean, judging by the answer options, it looks to be linear. So how can I take this table and turn it into a function? Well, if it's linear, right? Let's first identify if it is linear. So the way we're going to know if it's linear is if we notice a constant change in the x values, which it is, it's minus 50, or sorry. I guess that doesn't really tell us if it's linear. We can just assume it is based on the answer options. since it's not a constant change. That doesn't really, like what I was looking for is if it's a constant change here and a constant change here, then you know it's linear. But instead what you could just do is you can find the slope between these 2 points and then compare it with the slope between these 2 points. It will be equal because I've calculated it before. You can check if you like, and it says they're linear, so forget everything that I just said. All right, now how are we actually going to use that information to solve? So if I want to get a linear equation, I need to have a slope and a y-intercept, okay? So the slope I can calculate just by doing m equals y2 minus y1 divided by x2 minus x1. If I identify this as my x and this as my y, I can solve with just these 2 points, for example. So y2, y1, 70 minus 90 divided by x2, x1, 50 minus 100 equals 2/5. Okay, so my slope has to be 2/5. This is the only answer option. My y-intercept really doesn't even matter. Okay, it's a very simple problem. The sum of all the edge lengths of a cube is 36 inches. Which of the following is the cube's volume? So let's draw a cube really quick. Do this properly. If I draw out a cube and I conceptualize this, I can see all the edge lengths and know how many I have to add together. Okay, so just pretend this is a cube. It's not perfect. So I immediately already see 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. But that's not all the edge lengths because there's also edge lengths on the back that I can't see. So the cube goes down here, this comes out here, goes there as well, okay? So how many total edge lengths are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and I think I've marked all of them. Another way to think of it is you have a square on top, okay? That's 4 sides. You have a square on bottom, that's another 4. And then you have these 4 vertical things holding the 2 squares together. Again, that's 12, okay? So if the sum of the edge lengths is 36, that means that 12 times the length is going to be 36. That gives me an edge length of 3 for each, okay? Now, why did I just calculate all of that? It's because the volume, if I want the volume, what's the volume of a cube? It's the edge length cubed. Since I just calculated the edge length using the fact that there are 12 of them and that the sum of them is 36, I can just cube that value and get 27 inches cubed as my volume of the cube. One of the following systems of inequalities depicts the region inside of a circle and above a line to be shaded. Which one is it? So if you've watched the skill video for this skill, you'll know that if it's shaded, if the circle is shaded inside, that means that when I write out the circle equation, which is like this for example, that the side of the equation with the x's and y's has to be less than the side of the equation with the radius squared. Again, the radius squared here is 10. Okay. So in this case, if I'm shading inside of a circle, this side, the x's and y's side of the equation has to be less than. So that means c and d are out because they have greater than. Okay. If it was greater than, it would be outside the circle. All right. Now, above a line, what does this mean? So if I draw any line, like this one here, if we're shading above it, how do we know whether we should shade above? What does that sign look like? Is it going to be greater than or less than? Well, intuitively, it would be greater than. But can you confirm, right? How would you confirm that mathematically? One way to think of it as this equation is located here right now. There is a y-axis here, and the y-axis upwards, in the upwards direction, it goes on to positive infinity. And in the negative direction, it goes on to negative infinity, okay? When you draw your graph, when you shade the side of the graph that has positive infinity, if you're shading the side of the graph that has positive infinity, in this case above, that means that your sign is y is greater than, okay? When you write out your equation, if it's a very long equation, as long as the side that has y is greater than, that means that you're going to shade on the side of the equation, on the side of the line that has the positive infinity. Think of it as if y is greater than, then y could literally be infinity. Y could be all the way up here, here, here. You know, it could go on forever. It could also just be right above the line. It could also be right here, okay? So again, if the side of the line that has positive infinity is being shaded, that means you're shading a greater than equation, okay? For more detail on this, check out the skill video, but essentially we need to have a greater than sign here. That means that this is out. We can't have an equal sign because then nothing would be shaded, so that means your answer is A. In the interval here, sine theta equals cosine theta when theta equals what? Okay, so sine theta and cosine theta, when do they equal one another? Let's use the unit circle. So I'm not actually going to draw the circle, but I know that this is 0, pi over 2, pi, 3 pi over 2, and then it comes back to 2 pi, right? So we go around, I'll just draw the circle, why not? All right, when theta equals what? So I know, just based on the answer options, we're looking at multiples of pi over 4. So every 45 degrees, basically we're looking at here, 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 okay? So would sine 45, like this is 45 degrees, this is 135 degrees, this is 225 degrees, this is 315 degrees. Alternatively, you can think of it as pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, the easy way, the brute force method to solve this is to just plug in sine of 45, sine of 135, sine of 225, sine of 315, cosine of 45, cosine of 135, cosine of 225, cosine of 315, and see, make a table of all the values and see which ones equal and which ones don't. You'll find that 45, aka pi over 4, and 5 pi over 4 are equal to one another. So why aren't these two equal? Well, if you remember the acronym, draw that again, ASTC. Let me make it a bit more, let me make a new graph really quick. So what does ASTC mean? If you draw your coordinate axes, each of these corresponds to which of sine, cosine, or tangent is going to be positive in which quadrant. So in quadrant 1, which is here, in quadrant 1, all three of sine, cosine, and tangent are positive. In quadrant 2, only sine is positive. Okay, so if I do, like, for example, any angle in quadrant 2, like, let's do 120 degrees. Sine of 120 is positive, but cosine of 120 and tan of 120 are both negative. In the tan quadrant, aka quadrant 3, only tan is positive. Sine and cosine are negative. And here, only cosine is positive. So, now why do I bring this up to you? In quadrants like this and this, sine and cosine have the opposite signs. In quadrants like this and this, though, they have the same sign. So in order for them to be equal, they have to have the same sign, not just the same value. At all four of these purple points, they have the same value, but not the same sign. Okay, that's why you need to make sure that your sine equation has the same sign as the cosine. And that's how you do this particular problem. Use the figure below. Okay, so the figure below depicts a control tower's area of jurisdiction, which has a radius of 50 miles. So this is 50 miles. Looks like we have a few planes. So plane 1, plane 2, and plane 3 are three different aircraft at the very edge of the jurisdiction, meaning they're all 50 miles away from the tower. They are directly west, north, and east of the control tower, respectively. So we're going to use that to answer these 2 or 3 questions. Which of the following is the distance in miles between plane 1 and plane 2? Okay, so plane 1 and plane 2, that's the distance we're looking for. I know this distance is 50 because, again, it told us that plane 2, all these planes are at the edge of the jurisdiction, and this is directly north, okay? That's straight north. This is straight west. It says it's straight west, right? West, north. That means it's also 50. What I've just made here is an isosceles right triangle. I can solve for this last dimension using Pythagorean theorem or just the my 45, 45, 90 triangle rules. I'll know that this is 50 square root of 2. Or I believe that's, you can also find the equivalent of that in a decimal form. If you find the decimal form and you look at the answer options and you're not sure which one to choose, just find the decimal equivalents of the answer options, mainly just these two, and see which one it matches. It should match answer option B for question number 39. Plane 1 is heading east at 300 miles an hour. Plane 3 is at a lower altitude heading east at 200 miles an hour. After how many hours will they be directly above one another? Okay, so plane 1, let's just kind of draw that out. Plane 1 is going this way. or sorry, east is the other way. So east is this way at 300 miles an hour. Okay? Plane 2 is doing the same direction, but it's at a lower mile per hour value. So when will they be directly above? So this is kind of a hard question. The way you can conceptualize this is if I made an equation, a linear equation of the horizontal position of the aircraft, where the slope is the velocity, t is time, and then the y-intercept is the initial x position of the aircraft, which would be relative to the control tower. So let me say x on initial, right? I can create two equations, one for each aircraft, because they each have their own initial x value and their own velocities. T and x will be my dependent variables. Essentially, I've just made a y equals mx plus b. Except I made x a t because we're working with time. That's my kind of variable that I'm inputting, the independent variable. And then the dependent variable is going to be x, which is the, again, horizontal. It's the east-west direction of these aircraft, okay? So let's go ahead and make an equation for plane 1. So for plane, plane 1. So the x direction of 1 is going to be the velocity of plane 1, 300 miles an hour, times the number of hours, plus the original horizontal distance. So in order to find the original x value of each, let's just say we have a coordinate plane here, x, y, right? So the original x position of plane 1 is negative 50, because this is 50 miles this way. The original of plane 3 is positive 50, because it's 50 in that direction, relative to the origin, okay? We don't really care about the y value, so just ignore that. We're working with one dimension here. Okay, so I'm going to, for my x-intercept, essentially my xi value, I'm going to make this a negative 50. Okay, for the second plane, it's really plane 3, so I'm going to call it x3. I have a 200 mile an hour velocity, and I'm 50 miles in the right. So I'm positive 50 away, okay? So what I can do is if I make these two equations equal to one another, I can find when x1 is equal to x3. Essentially, at what t value do the x positions of these two planes align? I can go ahead and make the equations equal. Add 50 on both sides. Minus 200 on both sides. 100t equals 100. So t is equal to 1 hour. And that's your answer here, okay? After 1 hour, they will be at the same position. You can think of it as after 1 hour, since these are currently 100 miles apart, and this one's traveling at 300, this one's traveling at 200, after 1 hour, this one will be 200 further in this direction, and this one will be 300 further in this direction. It will have traveled 300 miles, aka 100, plus this 200, whereas this plane will have just traveled 200. So really, plane 1 is compensating that 100 because of that extra 100 mile an hour that it's traveling at. Plane 2 is circling clockwise, which is this way, around the control tower's edge of jurisdiction until it is directly east of the tower, at which point it turns straight towards the control tower and makes a landing. Assuming the final distance from the tower is 0, how far does plane 2 travel from its depicted position to its final position? Depicted position of plane 2. Okay, so it says plane 2 is traveling clockwise until it's directly east. So east is here. It travels clockwise until it's directly east, and then it goes straight towards the tower and essentially makes this path. So we have path 1 and then we have path 2. We need to find the distance of path 1 and path 2 and add them together, okay? Now knowing that path 1 is, we know that the radius is 50. So how can we get path 1? Well, we know that this entire thing is a circumference, so if I take the 1/4 of the circumference, I know what path 1 is. As for path 2, that's just going to be the radius, which is going to be 50. So that's the easy part. So I can immediately start canceling out answer options. I should have a 50 in my answer option. So it's either 100 pi or 25 pi. That'll be based on path 1, which is going to be the circumference, right? So circumference is what? 2 pi r, which is going to be 2 times pi times 50, which is going to be 100 pi. Now again, don't make the mistake of making this your answer, because 100 pi is one of the answer options, but it's not correct because we're not traveling the whole circumference. We're traveling 1/4 of the circumference. So we have to take 1/4 of the circumference, and that'll give us 25 pi. And that's equal to path 1. So path 1 plus path 2 is equal to 50 plus 25 pi. That's 41. Which of the following is a rational number? So let me first define a rational number. A rational number is any number that can be written as a fraction of whole numbers. So for example, square root of 3 over 2. This is not a rational number because square root of 3 is not a whole number. Square root of 3 is a never-ending decimal. I is not a rational number because it's an imaginary number. It's not a real concept. It's a square root of a negative number. However, I squared is a rational number because it's negative 1, which is effectively the same thing as negative 1 over 1. It's a fraction of whole numbers. They can be negative. Yes, they can. So, okay, just knowing that, again, numbers like pi, e, I, these are all irrational because they're not whole numbers, period. They can't be written as a fraction of whole numbers, okay? But for example, 5 over 7, it's a never-ending decimal, but that's a rational number, okay? So is this rational? You can rewrite this as square root of 2 over 3, but the thing is that doesn't simplify to anything, and that's a never-ending decimal. So because it's not a fraction of whole numbers, it's irrational. This is irrational because of pi. This is irrational because this is whole, but this is not. Sorry. This is whole, but this is not. So that's wrong. This is wrong because square root of 37 cannot be reduced to anything. That's a whole number, even though the denominator can. And this is correct because this is just the same thing as 3 times negative 1. It's negative 3. It's a fraction of whole numbers, effectively negative 3 over 1. Okay? That's how you do that problem. Given the following matrix, which of the following values of t will make the determinant of the matrix negative 9? Note that this is the determinant. So how do we make the determinant of the matrix negative 9? Well, let's just calculate what the determinant would be first. So that's going to be t squared, right? A times d, t squared, minus b times c, which is going to be bc. So let me just walk you through that one more time. Effectively, this is A, this is B, this is C, this is D. Okay, so A times D is T times T, minus B times C, 6 times T. And we want to make that equal to negative 9. Okay, let me rewrite this. T squared minus 6T equals negative 9. If you've seen a quadratic equation before, then you might know where this is going. I can move everything to one side. And then I can factor this and solve for t. You can also use quadratic formula. I think factoring is a bit faster. What are factors of 9 that equal negative 6? Well, the only factors that come to mind are 3 and 3, aka negative 3, negative 3. These two, when you add them together, they equal negative 6 when you add them. So we're going to do t minus 3 times t minus 3 is equal to 0. That means that t has to equal 3. If we want to get this criteria to be met, we have to have t equals positive 3. 43 is going to be D. Okay? Given that lines A and B are parallel and C and D are not parallel, which they clearly do not look parallel, which of the following is false? So, is angle 1 congruent to angle 3? These are congruent because of the opposite angles. They form an X. An extreme example is, for example, an X like this. Obviously, these two are very small, these two are very large. And you can use this as long as these two lines are straight, which all lines are. You can use this to conclude that the opposite angles are equivalent. So these are equivalent. 5 and 7. Like I said, same thing. If they form an X, they're equivalent. On opposites, 6 and 7 are not equivalent, but the opposite angles across the X are. Okay? 6 and 8. Same issue. These two are equivalent because they're opposite of the X. 2 plus 4 is it 180. 2 plus 4. So angle 2 is actually congruent to angle 4. Okay? The only way they'd be 180 is if both of these were 90 degrees, because they are the same. However, they're not 90 degrees, or we don't know that they are necessarily, because at least the way they're drawn, it looks like this is a little bit more than 90. Additionally, what this is trying to say, this is misconstruing the supplementary angles theorem, which says that two angles that are on the same line but that are being split by another line, essentially like 1 and 2, these form a 180 degree sum. Those are supplementary angles. However, 2 and 4 cannot be supplementary because they are opposite angles. Okay, so it's something very different. Opposite angles are not the same. They're actually very different from supplementary angles. For that reason, D is going to be your answer. 6 plus 7, on the other hand, these two are essentially, you see how they're adjacent, they're touching, and they are on the same line. In that case, they are going to be adjacent angles that are supplementary, they add up to 180 degrees. Again, supplementary is the same thing as adding up to 180 degrees, okay? When the two angles add up to 180 degrees. A 12-foot ladder is propped up against a 10-foot high treehouse with the base of the ladder on the ground and the top of the ladder touching the treehouse's base, as is in the following figure. Which equation will give the minimum angle the ladder must make with the ground to reach the treehouse's base? So we have two different angles here. We're trying to look for an angle that's made from the ground to the treehouse's base. So where's the ground? This, right? Because the ladder, this is the ladder. So let me just label that. Ladder, ground. Where's the treehouse base? Is this the treehouse base? Not quite. The treehouse base is an imaginary thing up here. Okay. So we're looking for the minimum angle the ladder must make with the ground. So the ladder is making an angle with the ground right here. Okay. So whatever answer option we choose has to have a theta in it, which means these angles of phi, this is called phi, those are all out. Okay. So which one do we choose, cosine or sine? Well, if I do sine of theta, that's creating a relationship between opposite and hypotenuse. Okay, that's going to be 10 over 12. So this is correct. The ratio is correct. Cosine of theta is what? It's adjacent, so 2 squared of 11 over 12. Now, how do I choose between these two? Well, the issue is sine is not relating the ground to the ladder. Rather, it's relating the height, overall height, the 10-foot dimension to the ladder. And we're not asked about the height versus the ladder. We're asked about ground and ladder, which is essentially adjacent and hypotenuse. Since adjacent and hypotenuse are what a cosine ratio describes, we're going to choose the cosine ratio in this particular problem. Okay, moving on. A water tank has an initial volume of V equals 0 gallons at 8 a.m. The volume of water in the tank is checked at various times as described in the table below. In which time frame was the flow the highest? So what you're going to do here is you're going to solve essentially for flow rate. Now what's flow rate? It's the amount of flow divided by the amount of time. So for example, if 10 gallons flow in 20 minutes, that means you have, or 10 gallons in 10 minutes, that means you have 1 gallon per minute, right? 10 gallons in 20 minutes would be half a gallon per minute. So in this case, you want to find how many gallons per minute or gallons per hour are flowing. The way you're going to do that is you're going to look at each interval. So you have an imaginary interval that's not plotted here in the table. You have 8 a.m. where you have 0, okay? So you want to find in each interval what's the flow rate and find which one's the highest flow rate. So if I look in this interval, what's my flow rate? I'm doing about 34 gallons in 2.4 hours, okay? So if you do 34 divide by 2.4, you get 14. 14, okay? Now in this interval, I'm doing 14 gallons in about 68 minutes, which is some other number of hours. 68 divided by 60. So that's, that gives me about 12.3 gallons per hour. In this interval, I'm doing a lot more gallons, but I also have a much longer time frame, about, you could say 7 hours. Let's just say it's 6.8 hours, 6.7, 12 and a half. So again, this one is still by far the largest interval, from 8 a.m. to 10:24 a.m. And then my last interval, at least the just between consecutive values, 170 minus 133 gallons. Again, I'm just comparing, really what I'm calculating each time is 177, at least in this case, right? I'm calculating 170 minus 133 divided by the time that's elapsed. You can think of it as minutes or you can think of it as hours, okay? You're really just doing the m equals y2 minus y1 divided by x2 minus x1. You're doing that formula here, okay? So in that last interval, how much time passes? It looks like it's about 3.5 hours. So I'm going to do 37 divided by 3.5. That gives me about 10.57. Now the very last interval was, it's listed here, 8 a.m. to 11:32. So it's going from here to here. It's skipping the 1024, so we do 48 gallons in that amount of time. Over from 8 a.m. to 11:32, that's 3.5 hours. So 48 divided by 3.5. 48 divided by 3.5. That gives me 13.7. So by far the highest amount of water is in the 8 a.m. to 10:24 a.m. Interval. Okay, so you kind of have to take time to check through these values, but it's really a test of how you interpret flow rate. And once you do that, the rest of the calculation is pretty trivial. The standard coordinate plane and its quadrants are shown below. In which two quadrants does the line not appear in? So what does that line look like? It looks like this. Okay, it goes straight through the origin. And it's going to go straight through the origin, like that. It does not appear here or here, so 1 and 3. You can also graph it on your graphing calculator if you're not sure, and the quadrants are obviously labeled, so that makes it a lot easier. Moving on. Below is the blueprint for a backyard patio design. The center fountain is a square with side length 4 feet. The entire patio is a square with side length 30 feet, so 430. Which of the following is the ratio of the fountain's area to the rest of the patio's area? So we're comparing this area right here with this area right here, okay? So how do we find which one's bigger? Or not which one's bigger, obviously we know that, but we have to just find the correct ratio, the correct values, okay? So what's the patio area? That's going to be 30 squared, but we're going to subtract the fountain area. That gives us 884, okay? It's just 900 minus 16. The fountain is going to be 4 squared, and that's 16. Okay, so your ratio is going to be 16 to 884. So your answer for 48 should be B. The sum of two numbers is 25. The smaller number squared, so I'm going to, let me first finish reading it, then we'll write it out. The smaller number squared is 14 less than half of 160. What's the larger number's square? Okay, two numbers. So let's just create two numbers, two variables, x and y. It says the sum is is 25. The sum is when you add them together. The smaller number, let's just say, is x. So small, you can assign it. It doesn't matter how you do it, as long as you stick to what you assign. It doesn't really matter how you assign them, x or y, okay? The smaller number squared, the smaller number is x, squared is, that's going to be equals 14 less than something. So it's going to be something minus 14, half of 160. So 160 is 160, and half is just going to be half times that, or essentially just 80, right? So this second equation gives us x squared is equal to 80 minus 14, and that's equal to 66, which really just tells us x equals square root of 66. I can plug that into this equation and get y. Okay, that's just going to give me one unknown. So square root of 66 plus y is equal to 25. Y is equal to 25 minus square root of 66, and that's going to be 25 minus second square is 66. That's going to be 16.875. Okay. Now, if the question is not asking for the larger number, it's asking for the larger number square, which means what's y squared equal to? Y squared is going to be equal to 285. Okay, that's how you do this problem. It's just a few terms you have to convert from word to algebraic. Which of the following is the number of solutions the two functions below have in the region -2 is less than or equal to y is less than or equal to 2? So the way you're going to solve this is you're going to make the y's equal to one another, or essentially make this equation equal to 2x minus 4. I can go ahead and subtract 2x and add 4 on both sides, just so that I get everything on one side. So that becomes x squared minus x minus 2 is equal to 0. Now I can factor this. So I have to think about factors of -2. That gives me -1. So it's either -1, 2, or -2, 1. Since I want a -1, I need to have the bigger number be negative. So x minus 2, x plus 1. That means we have x equals 2, -1. Okay? Now, you might think, all right, these are both between the region here, so is that correct? No, because these are x values. So you're not going to just you have to hold your horses. It's not two real solutions, at least not based on this information. So let's save this piece of information. Let's finish the rest of the problem, but we're gonna keep that in mind, okay? So how do we use that piece of information to actually get an answer for this? What you're going to do is you're going to plug in these x values into my equation, any equation for y. You're going to get the same answer for y no matter which one you do. So might as well just use the simpler one. So y1, we'll just call it, is going to be 2 times 2 minus 1. Sorry, minus 4. y2 is going to be 2 times negative 1 minus 4. So y1 equals whatever that is, 0. y2 is equal to negative 2 minus 4, which is negative 6. Now, these are the y values that correspond to the x value. So your coordinate pairs of your answers are 2, 0, and negative 1, negative 6. Again, 0, negative 6. Well, now you can consider which ones fit in these regions. This one does not. So you have one real solution that fits in that region. Now you might be thinking, what about an imaginary solution? An imaginary solution would exist if you had something along the lines of negative 1 plus or minus I. Okay? Where this, or let me put it this way. It would have to be negative, it would have to be A plus or minus B times I, where A is in this region. A is a constant that is between negative 2 and 2. Okay? If that was the case, then we would have one real and one imaginary solution. But the thing is, when you have one imaginary solution, you usually have another. So in this case, you don't just have one. You have just one real solution. The other solution just doesn't fit in the range. Okay? That's how you do this problem. If the period of y equals cosine of 3 over 4x is 8 pi over 3, then the period of y equals cosecant 3 over 4x is what? So you can go ahead and graph the equation. You'll find that the equation has the same period of 2 pi over b for any and all trig functions, where b is just the value in front of the x in your equation. So if you were to write it out like this with the parentheses, the b value is just in front of the x, okay? So in this case, b equals 3 over 4. So period equals 2 pi divided by 3 over 4, which is equal to 4 times 2 pi over 3, and that equals 8 pi over 3. Same period, same equation, regardless of if you have secant, cosecant, cotangent, etc. A regular tetrahedron is a 3D figure made of 4 equilateral triangles. A certain regular tetrahedron has a surface area x and a side length L. Which of the following is the sum of its edge lengths expressed in terms of x? Okay, that's a lot of information. So we're essentially given surface area. We are given, and we want to find the edge lengths, essentially, expressed in terms of the variable x. So how do we get anywhere near something like this? The way you're going to do it is, first of all, let's try to draw a tetrahedron. So we have a triangle. It says equilateral. So let me draw an equilateral triangle, something like that. I'm not going to draw it equilateral, actually. We're going to draw it like this. So we have a triangle. Then we have another triangle, and then we have a triangle in the back, okay? So you have one face here. That's your first triangle. Another face here. It's your second triangle. Another face on the bottom. Third triangle. And then a face in the back. Fourth triangle, okay? So those triangles are all the same. They're equilateral. They all have the same dimensions, okay? That's an assumption that we're allowed to make. If they were different triangles, then we would not be able to call it a regular tetrahedron. Okay, so the surface area is really just 4 times area of triangles. All right, and we can assume, like it says here, that they have an edge length of L. So if I give a triangle here, and I say this, how can I find the surface area of this triangle? Well, I know triangle is just base times height. And if it's equilateral triangle, you don't know the height. We're not given an h value, but what you can use is the general form of area of a triangle, where A and B are just any two lengths, and C is the angle between those two lengths. So if I say this is side A, this is side B, that means that this angle right here is angle C, okay? I know A and B are all going to be equal to L, so these just substitute out as L. Sine C is what? What is C? So C in this particular triangle is the angle of 60 degrees, because all the angles are 60 degrees. It's an equilateral triangle, right? So area is going to be equal to half L squared sine of 60. What's sine of 60? That's going to be equal to square root of 3 over 2. So area is going to be equal to L squared square root of 3 over 4. That's the area of one triangle. Now, we have 4 triangles, so the surface area total is going to be equal to L squared square root of 3. Simple as that. It's just L squared square root of 3. So surprisingly simple considering that we have 4 triangles, we have different angles, we have a sine ratio. That's what we come out to, okay? And what does it say? The surface area is equal to x. Okay? Now, how do we take this surface area? We want to look for the sum of the edge lengths. So how do we take that and convert it to a sum of edge lengths? The good thing is I have a drawing here. So I can actually count the edge lengths in my drawing. How many edges are there? So I have one here, one here, one here. I have 3 kind of going up to this one point, right? And then I have this triangle on the bottom. One here, one here, one here, in terms of side length. So I have 6 edges, right? So the edge lengths are obviously they're just going to add up to 6 times L. But we need to express 6L. This is technically your answer, but we need to express 6L in terms of x. So how can I do that? I can express 6L in terms of x by solving this equation for L and then plugging it in here. So solve x equals L squared square root of 3. Solve it for L, sorry. So I'm going to divide it by square root of 3 and then take the square root. So so first divide by square root of 3. L squared equals x over, and then I'm going to take the square root of both sides. Now, I have a square root of a square root in the denominator here. This effectively reduces to this, right? Square root of a square root of 3. That can be reduced to 4th root of 3 because it's 3 to the half, which is just going to be, if you have an exponent to an exponent, you multiply the exponents. That becomes 3 to the 1/4, which is just the 4th root of 3. So that becomes square root of x divided by 4th root of 3. Now you can see we kind of have a form that looks like this, right? And that's equal to L. So this is your key equation right here, and we're going to combine that with this. So if this is what L is equal to, what's 6L? 6L is going to be equal to 6 times this thing. So 6 times square root of x over 4th root of 3. 6 square root of x over 4th root of 3. That's what that is, okay? Pretty hard problem. It's complicated, but as long as you have the visualization down, you're able to find surface area, and you're able to interpret that there are 6 edge lengths. The rest of it is just simple algebra, moving things around. Definitely a hard problem. That's why it's in the last 10 problems. Which of the following are the solutions for the below inequality? So when you have an inequality like this where there are essentially 3 components and you want to solve it for x, what you have to do is isolate the x. You can isolate the x by getting rid of the 18 and -2 and moving them to the other parts of the equation. So let's start by doing that with the 18. Subtract 18 from all 3 sides. You end up getting -14 is less than -2x is less than -8. Now the last step to isolate the x is to divide by -2. This is the tricky part. So you can go ahead and divide by -2. But the thing is, when you divide an inequality or multiply an inequality by a negative number, the direction of the signs change. They reverse. So you're going to have 7 is greater than x is greater than 4. You can write this in a more conventional form by reversing it, essentially moving the 4 here and flipping the sign again. So 4 is less than x is less than 7. Again, these two are equivalent. It's the same exact thing. I just wrote it in a reverse order, so it's just easier to interpret. Smallest to largest, right? Now, this is your answer, but none of the answer options are written in this form where it's combined. You're going to have to take this inequality, compound inequality, and split it into 2 inequalities. So we have 4 is less than x, and then we have x is less than 7. Or essentially, if I want to rewrite this, this is x is greater than 4. X is greater than 4, x is less than 7. That's what A is. All right, that's how you do this problem. For the geometric sequence with first term 1 and third term 16, what's the sum of terms 4, 5, and 8? Okay, the easiest way to do this problem, you could do it with a of n equals a1 r to the n minus 1, and you can find all the terms and do that summation that way. Probably the easier way is to just take the terms and write them out. So I know that term 1 is 1. Term 2 is unknown. Term 3 is 16. Okay. If you think, what could this possibly be? What could the common ratio possibly be? let's just test some numbers. So it can't be times 2, because if it was times 2, then this number would be 4. It can't be times 3, because if it was times 3, this number would be 27. Or sorry, it would be 9, not 27. What about times 4? Can it be times 4? Yes, it can, and it actually is. So the common ratio, r, is going to be 4. And you can extrapolate that out to terms 4, 5, 6, 7, and 8 to essentially complete your sequence and very easily get all your values. So we have 1, 4, 16, 64, 256. Again, I'm just multiplying by 4 each time. 5, 12. I think it's 10, 24. How many do we have? 7. We need one more. And then 40, 96. Okay? So we need to add the sum of terms 4, 5, and 8. So if you take a calculator, you do... Oh, I just realized I made a silly mistake. So this is actually not being multiplied by 4 each time. I multiplied by 2 to get to 512. So 4 is going to give you 1024, and then 4096, and then 16, I believe. So what's 4096 times 4? 16384. Okay. So I'm going to add, these with these two. 4, 5, and 8. Okay. So 64 plus 256 plus 16384 is 16704. Okay. That's your final answer. That's the sum of those terms. What does this expression simplify to? So I can use the FOIL method here. So I'm going to multiply my first terms in each parentheses, and then the outer terms, and then inner, and then the last. So 6i times 6i plus 6 times 6i plus 6i times negative 6 plus 6 times negative 6. Okay? This becomes 36i squared. This becomes right here 36i. We get plus negative 36i. So I'm just going to write that as 36i negative. And then we have plus negative 36. That's minus 36. Okay? When we can combine these terms, which you'll notice is the middle two are just opposite sign, same value. So you can cancel those two out. As for this I squared, you remember that I squared is equal to negative 1. So multiplying by I squared is just the same thing as multiplying by negative 1. So your answer is going to be 36 times negative 1 minus 36, which is negative 36 minus 36. That's equal to negative 72. Nope, it is B, which is 55. Which of the following inequalities represents the values less than 8 units away from 3? So how do you solve this type of problem? If you don't understand how to interpret this, but you know how to solve absolute value inequalities, you can go ahead and solve each one, and based on the solution, see which of these gives you a value, or gives you a range of values that are all values less than 8 units away from 3, or essentially values in the range 8 plus 3, 8 minus 3. It should be, you can think of it as 3 plus 8, 3 minus 8, which is going to be, again, 11, negative 5. Okay? So that's how you can do this type of problem, and that's probably the best way to do it. The way to properly interpret it is the x minus something. That part is just a locator. So the locator is 3, right? That's the center point that we want to be based around. So we want to have x minus 3 in the equation. So that means that your answer is going to have to be D or E. Now, as for the outside, what does the outside number represent? This represents the range or the distance that you can travel. So we want to be, from x minus 3, we want to be within 8 units of that number. Now, how do we choose this sign? Well, this just tells us, do we want to be more than 8 units or less than 8 units? Like, do we want x minus 3 to be more than 8 units away? Or do we want our x value essentially to be more than 8 units away from 3? Or do we want it to be less than 8 units away from 3? So if you choose greater than, you're going to have, again, you're going to be outside that range. We want to be within that range, values less than 8 units away. So your answer should be E, just based on this interpretation. Let's go ahead and check that, see what we get when we plug these in. So x minus 3, if I solve this, is less than 8. X minus 3 is greater than negative 8. This becomes x is less than 11, and this becomes x is greater than plus 3, negative 5. So between negative 5 and 11, are these all the values that are less than 8 units away from 3? Yes, they are. What you'll find is if you solve any of these others, you will not get values that match up because, well, this one has an equal to sign. This says less than. It doesn't say less than or equal to, so for that reason, this is wrong. As for a, let me try that one. So x minus 8 is less than 3. This gives you x is less than 11, which is correct, but it'll also give you x minus 8 is greater than negative 3, which is going to give you x is greater than 5, which is clearly wrong. 5 is not 8 units away from 3. So that's out. You'll get a similar result here. You'll probably get an x minus 5 here. X is less than 5, and that doesn't make sense. You'll get, and this is the same thing, but it has the wrong sign. So you'll get reversed signs here, which again, that does not make sense. Those are going to give you values more than 8 units away from 3. Given the following equations, find how many z-intercepts f has, as well as the number of solutions f and g have. Okay, so z-intercepts that f has. Based on this, what are the z-intercepts? Well, I just set this equal to 0. And the thing is, it's already factored for me, so I know that z has to equal 3. But the thing is, that's the only z-intercept that I was able to find. So I only have one z-intercept. The only thing we need to figure out now is how many solutions are there. How are we going to figure out the number of solutions? It's by setting f of z to be equal to g of z, and finding what z values we get and how many we get. Okay? So let's do that. How many z values? So the way I can set these equal is I can expand this out. This will become z squared minus 6z plus 9. And I set that equal to 2z minus 7. So z squared minus 6z plus 9 is equal to 2z minus 7. I want to move everything to one side and then try to factor it. That'll probably be the most logical thing to do. Add 7 minus 2z, add 7. So we get z squared minus 8z plus 16 equals 0. I can go ahead and factor this. What are the factors of 16 that equal negative 8? I see negative 4 and negative 4 are a perfect fit. So I end up getting z minus 4 is equal to 0. That means that z has to equal 4. But the thing is, I only have one solution again for this factored form of the quadratic, which means that this is the only solution of the equation. Okay? There's only one solution because there's only one factor in this combined solution here. On a 10-question test, a student has a 1/4 chance to guess any question correctly. Okay? Which of the following is the probability that the student guesses and scores 0? So if you have a 1 out of 4 chance of getting it right, that means you have a 3 out of 4 chance of getting any given question wrong. Okay? Now, none of the answer options here are equal to 1 out of 4 or 3 over 4 as a percent. So why is that the case? What you're going to have to do here is not just find a fraction, but you're going to have to take your fraction probability of 3 over 4 or 1 over 4 and raise it to a power. That's because here you're dealing with essentially compound probability. When there's a variety of events or independent events and you want to find the probability of all those events happening together, in this case 10 questions being answered incorrectly together, you have to multiply the probability by itself that number of times, okay? So you have your probability of getting a question wrong. You need to raise that to the 10th power because this has to happen 10 times. And whatever this value is, that's your answer. So take 0.75, raise it to the 10th, and you end up getting about 5.6%. So if you take a 10-question quiz and you're thinking worst case scenario, what's the probability that I get everything wrong? It's about 1 out of 20, which is strikingly high. It's kind of alarming, which is why you should study. But that's how you do this type of problem. If, on the other hand, they asked you what's the probability of getting all the questions right, it would be this, and that's a much smaller probability. So if you look at that, 1 over 4 to the 10th, that is 0.000009536. Compare that to 0.056. This is like 6 magnitudes or 5 magnitudes smaller, okay? So it's much easier to get everything wrong than to get everything right. The cross-section of a paper towel roll is shown below. So the inner radius is 0.75 inches. The outer radius is 3 inches. If the height of the paper towel roll is 1 foot, what is the approximate volume of paper towel in the roll? Assume that paper towel sheets in the roll lay flat against each other. Okay, so you know what a paper towel roll looks like. It's like this. It's kind of vertical, right? So effectively, that's what it is. And we have a hole going through the middle. And there's like a hole down there too. Yep, that's what a paper towel roll looks like. Okay. So how do we? It's effectively asking what's the volume of this region here. How do you find the volume of that cylindrical region? Well, what you can do is you take the equation of the volume of a cube, pi r squared times height, and you modify the r squared value to be the difference in r squareds. So r1 is going to be your bigger radius, your maximum radius. R2 is going to be your minimum radius. Okay? You can also think of it as you're finding the difference in area. So the area of this large circle is going to be pi r. I'm going to capital R for large. And then the area of the small circle is going to be pi r squared. Okay? You can find the difference in those areas by just doing pi r squared minus r squared. And then if you multiply that value by the height, you'll get a volume of this region if it was extruded out vertically. Okay? So if you just do that, you'll get volume equals pi times 3 inches squared minus 0.75 inches squared. Multiply that by 12 feet. 12 inches per foot, sorry. And you end up getting some value. Let's calculate that really quick. So actually, let's just do it in fraction form because I see the answers are still in fraction form. So that'll be pi times 9 minus 3 over 4 squared times 12. That becomes pi times 12 times 9 minus 9 over 16 equals pi times 12 times, we want to get a common denominator, so I'm going to multiply 9 by 16. We get 144 over 16 minus 9 over 16. That becomes 12 pi times 144 minus 9 is 135 over 16. So if I multiply that, 12 and 16, I end up getting 3 over 4. 135 times 3 is what? So we end up getting your final answer, 405 pi over 4. Okay? Again, if this whole algebra thing at the end does not make sense to you, don't worry about it. Just find the decimal equivalent, plug this into your calculator. It's one step, very simple. Find the decimal value, and then just plug each of these into your calculator and match the decimal value with what you get here. For which of the following sets is tan of theta less than or equal to 1, where theta is in radians? So in order to solve this, I'm going to draw out the unit circle. It'll make it a lot easier if I visualize what's happening and I can see the problem as opposed to just thinking through it in my head, okay? So just to start, we have the x-axis, the y-axis. I'm going to draw a circle. Actually, we don't need the circle here. I'm just going to plot the points. So we have 0 degrees, pi over 2 degrees, negative pi, so we have pi degrees, and then we have 3 pi over 2, and then this goes up to 2 pi, which is just the same thing as 0, okay? Now I want to analyze tangent at each of these, like all around the circle, and see what region, or what are the various values, how does tan like kind of vary throughout the unit circle, okay? The way I can do that is, let's just analyze tan at each of these points, okay? So tan of 0 is just going to be 0. Tan of pi over 2 is going to be what? Let's do tan of 90, see what I get. I get positive infinity. How do I know that? Well, on your calculator, that's not actually going to work. What you need to do is you need to plug in tan of 89, for example, and see what number it gives you. Tan of 89 is 57. It's just a very large number. If you do tan of 89.999, you end up getting 57,000, right? So you're essentially looking at positive infinity here. What about here? Tan of 180, it's 0. And then tan of 3 pi over 2, again, we would imagine it would be negative infinity, okay? So we want to be less than or equal to 1. I imagine these numbers are all negative, right? Well, actually, hold on. We know A, S, T, C. We know that tan's positive here. So in that region where like tan is, for example, 225, what's tan of 225? We're at 1. So here, tan is 1. If we look at 45, tan is also 1. If you again, you can check that on your calculator. What about here? Well, here it says sine is positive. Remember ASTC? all students take calculus. This is the acronym that tells you in which regions of the unit circle, which of the trigonometric functions, sine, cosine, and tangent, are positive. So here in this quadrant 1, A, all of the functions, sine, cosine, and tangent, are positive. Here only sine, here only cosine, okay? So since tan is negative here, we're not going to have, we can include this region in our analysis, but you're not going to exclusively have this region. So that's not really super conclusive right now. Let's just keep that in mind. Tan is going to be -1 here. Okay, so that definitely could be part of our answer. Same here, tan is going to be -1 at -45 degrees. Now, again, how do we get closer and closer to an answer? So between 0 and 1, I know for sure this region works, right? Because I know tan is 0 here and 1 here. So this region for sure makes sense. I can include this as part of my final answer. What about this region right here? Because this is -1. I mean, I guess it works, right? So this part down here, if I do, like, for example, I know this is 270 degrees, right? The 3 pi over 2. I can check if this region works in our final answer by just checking tan of 271, for example. So that gives me -57. So this does work. This is less than 1. Okay? This region works. That means this region should work as well. Okay? What about this region? Does that region work? Again, let's just check, for example, tan of 70. That gives me something like 2.7. So that doesn't work. So I'm going to label this as red. This is out of consideration because it's just too big. What about here? Let's test something like tan of something greater than 90, tan of 110. Can't be too much bigger because otherwise we'll end up in a different region. So this does work. It's less than 1. So that's fine. What about this region right here? Let's do something a little less than 180 degrees. So tan of 179. Yep, it's negative as well. This works too. What about this region right here? So if we're at 0 going to 1, then this region would make sense, right? Right? Because we're just going from 0 to 1. That makes sense. So anything here is going to be between 0 and 1. It's going to be less than 1. But this region right here, again, since we know that this goes to, I believe this goes to negative infinity. So let's see what happens. So let's see if I do tan of 269. 57. So this actually becomes greater than the limiting value. So this region does not work. Okay, so we can't do that region. All right. Now let's take all that and bring it back to the answer options. You don't have to do this first. You can just solve this problem by checking each answer option. But if you look at A is effectively this region right here. Okay, so it actually works. If we look at B, it's 0 to pi over 2. That region doesn't work because it includes this part from pi over 4 to pi over 2. This region here, -3 pi over 4, is this, up to pi over 4, which is that. That does not work because it includes this red region here. Okay, so for that reason, that's out. -1 up to 6. So this is just, again, this is still radians. It's a weird way of writing radians. Usually it's written as a multiple of pi. But again, -1 radian, if you check what that is, it's so if you compare that with pi over 4, what's pi over 4 itself? Pi over 4 is just less than 1 radian. So -1 radian is going to be right here. 6 radians, though, if we look at like pi, right? Pi is here. That's 3.14 radians. So 6 radians is going to be literally, we're going from this region all the way back to like here almost. And that obviously includes a lot of red, so we can't do that. Same thing happens here. If you go square root of 2 over 2 radians, that's really just about the same thing as pi over 4, the value of it. This is about equal to pi over 4. So this is saying if we go from pi over 4 about to here, I think. It definitely includes this region as well. So for that reason, that's wrong. So we can't do this answer option either. So the correct answer is going to be A because it includes only the yellow region that we can actually be a part of. All right. That's it for this video. Hopefully this was helpful.